Welcome to the first video on this channel and also the first video on our series on calculus. We're going to start with finding limits because finding limits is a very important concept for calculus students to understand. So what is a limit? Well, the limit of a function at a value of x is just what the y value approaches as we approach that x value, which that definition alone might not be very helpful, so I think explaining what it is with an example will help. So, given this graph of f of x, the limit of f of x as x approaches 4 from the right is written as, well, first our notation here, right? Limit, LIM means limit, of f of x as x approaches 4 from the right. So this plus just means from the right. Equals, well, what is it equal to? We start from the right of x equals 4, and the closer and closer and closer we get to x equals 4, the closer and closer y gets to 1, right? So, as we start from over here, the closer we get to x equals 4, the closer our y value gets to 1. So the limit of f of x as x approaches 4 from the right is equal to 1. What about the limit of f of x as x approaches 4 from the left? So the only thing different here is now is from the left, so our superscript becomes a minus. Well, starting from the left, closer and closer we get to x equals 4, the closer we get to y equals 1, right? It's the same. So, therefore, the limit of f of x as x approaches 4 is written as limit f of x approaches 4, there's no superscript this time, equals 1. So hopefully you got all that. Let's just move on to our next thing, which is, what if the limit from the left is different from the limit from the right? Well, what is the limit from the left of g of x now as x approaches 2? Well, first let's write out in our notation, limit of g of x as x approaches 2 from the left. Well, starting from the left of 2, we see that our function slowly, the y value approaches -3, right? So if we start from the left, g of x, or y, approaches -3. Okay, what about from the right? Well, the limit of g of x as x approaches 2 from the right is equal to, closer and closer we get to x equals 2, starting from the right, we get closer and closer to y equals 1. Now, even though we already are at y equals 1, we still say that we are approaching y equals 1 here as we approach 2 from the right. So the limit of g of x as x approaches 2 from the right would be equal to 1. But what would the limit of g of x as x approaches 2 be? Well, the limit g of x as x approaches 2 without any superscript would not exist. So I would write does not exist. Because, well, in order for a limit to exist, the limit from the left has to equal the limit from the right. That's not the case here, so we say that the limit does not exist. Moving on. Continuity. Continuity is another important skill for calculus students to have. There are 3 conditions that a point must meet in order for it to be considered continuous. Number 1, f of a, and a is just a value of x. F of a is defined. Defined just means that there is a value of y that corresponds to that value of x. Number 2, the limit of f of x as x approaches a exists. And 3, the limit of f of x as x approaches a is equal to f of a. So, let's do an example. Consider the graph f of x. Is the graph of f of x continuous at x equals -1? Well, first thing you might notice is that there's a hole right here, right? At x equals 2, there's a hole. But right now we're focusing on whether or not it's continuous at x equals -1. So we can actually just ignore that and move on to our first condition here. Well, is f of a defined? A, in this case, equals -1, which means that we're looking to see if f of -1 is defined. Well, good -1. We see that, yes, f of -1 is defined. It is defined as 1, right? So condition number 2. The limit of f of x as x approaches a. Does that exist? Well, from the left, we start from the left of -1. Closer and closer we get to -1, the closer and closer our y value gets to 1. What about from the right? Well, the closer and closer we get, starting from the right of -1 to -1, the closer we get, the closer our y value gets to 1. So the limit of f of x as x approaches -1 equals 1. So our third condition, does that check? So does f of -1 equal the limit of f of x as x approaches -1? Well, yes, right? 1 certainly equals 1, which means that all three of these conditions check, right? F of -1 is defined, the limit of f of x as x approaches -1 exists, and f of -1 equals limit f of x as x approaches -1. So if this were a multiple choice question on our AP exam, we would just circle whatever answer said that f of x is continuous at x equals -1. But if this were a free response question, we would have to write out our reasoning. So I'm going to do that now. Yes, f of x is continuous at x equals -1 because f of -1 is defined, the limit of f of x as x approaches -1 exists. So for points we say it's defined or undefined. For limits we say they exist or they don't exist. And because f of -1 equals the limit of f of x as x approaches -1. So that would be our answer. And we would move on to question number 2. So, what is our first condition here? We need to find if f of a is defined. Well, a right now equals -2. So f of -2 equals, we just go here, it equals 1, right? Then the limit of g of x, there we go. Okay. The limit of g of x as x approaches -2, well, from the left, closer and closer we get to x equals -2, the closer and closer y gets to 1. Closer and closer from the right as we get as x approaches -2, the closer and closer y gets also to 1. So the limit of g of x as x approaches -2 equals 1. And even though our y value already is at 1, we still say that it is approaching 1, even though this is, of course, just a line that's parallel to the x-axis. Okay, number 3. Does g of -2 equal the limit of g of x as x approaches -2? Well, does 1 equal 1? I would say that it does, which means all of our conditions check. So we would write, yes, if this were a free response question, we would write, yes, g of x is continuous at x equals -2 because g of -2 is defined, the limit of g of x as x approaches -2 exists, and g of -2 equals the limit of g of x as x approaches negative 2. Okay, moving on to number 3. Checking our first condition, is f of a defined? Well, right now a equals 3. So is f of 3 defined? No, it is not. F of 3 is undefined. Right? There's no value where x equals 3. There's a hole here in our graph. Therefore, oh my, I did the exact same mistake. Okay. H of 3. Okay, h of 3 is undefined. Therefore, h of x is not continuous at x equals 3 because h of 3 is undefined. So we know right away after we check the first condition and it fails that it doesn't matter if the other two conditions are checked. Well, the third one can't be checked because it means that this has to be defined. But we don't have to check the other two conditions to know that it is not continuous because we know that all three conditions have to be checked and the first one wasn't. So h of x is not continuous at x equals 3 because h of 3 is undefined. So, thank you for watching this video. As you probably could tell, I was a little nervous. But hopefully, as I get better at making videos, you will get better at calculus. So I will see you guys later. Bye-bye. Sorry, one last thing that I realized that I did not address here is what the difference between the limit of a function at a value and the actual point at that value. So we got here that h of 3 is undefined, but the limit of h of x as x approaches 3 actually would just be equal to 2, even though it never actually, there's a hole here, it never actually gets to 2. That doesn't matter because from this side it's approaching 2 and from this side it's approaching 2. So just one thing I wanted to clarify is that the limit actually would exist in this case. Alright, see you later.